When you hear the word multiplication, you probably flash back to elementary school, right? But here's a different way to think about it. It's not a subject, it's a problem humanity has been wrestling with for over 4,000 years. So today, we're going to see how that simple chart from your classroom wall is actually a profound piece of ancient technology. You know this thing. You've probably seen it a million times. The standard multiplication grid. It's so common, so baked into how we learn math, that we don't even really see it anymore. We look right through it. But this grid, this isn't just a learning aid. It's an invention. And that's really the heart of it. This little grid is the end product of a quest that spanned millennia, a search for the perfect tool for calculation. You could even call it the silent engine that powers all the math we do by hand. So in this explainer, we're going to pull back the curtain on that secret. We're going to trace the incredible story of how different cultures tackled this ancient mathematical challenge and how this simple, elegant grid became the ultimate answer. This is the question. This is what drove thousands of years of innovation. It's not really about what multiplication is, repeated addition. It's about how you actually do it, especially with big, messy numbers. And the answers people came up with, they're just absolutely brilliant. Our story really kicks off in the ancient world, with two totally different philosophies for solving the exact same problem. On one side, you've got the Egyptian scribe, and on the other, the Babylonian mathematician. And this line really lays out the core conflict, the big debate. The Egyptians, they came up with a clever process, a kind of algorithm that could solve any multiplication problem from scratch, right on the spot. But the Babylonians, they went the other way. They built a database. They just pre-calculated a ton of answers and turned multiplication into an exercise in looking up the right information. Okay, so let's dig into the Egyptian method first. They called it duplication and mediation, which is a fancy way of saying doubling and halving. And it's pure genius, because it meant anyone could multiply any two numbers using only 3 skills: doubling a number, cutting a number in half, and adding things up. That's it. No times tables to memorize. All right, let's actually try it out. We'll multiply 25 by 7. So you make 2 columns, you just keep halving the number on the left, and don't worry about fractions, just drop them. And you keep doubling the number on the right. Then you look at your left column and cross out any row that has an even number. The last step? Just add up whatever numbers are left on the right side. So 7 plus 56 plus 112 gives you 175. Pretty cool, right? It just works every single time. But wait, because this is the truly mind-blowing part. The Egyptians had no way of knowing this, but what they had actually invented was a perfect binary multiplication algorithm. I mean, this process of halving and checking for odd numbers, it's just a physical way of converting the number 25 into binary code, which is 11001. The exact same logic of shifting and adding is fundamentally how your computer's processor does multiplication right now. It's incredible. Now, let's jump across the ancient world to Mesopotamia. The Babylonians took the complete opposite path. Instead of focusing on a clever process, they focused on data. They used their super advanced base 60 number system to create these huge libraries of multiplication facts, all recorded on clay tablets. So, if you were a Babylonian scribe, doing multiplication wasn't really about calculating at all. It was about querying your database. To solve, say, 23 times 57, you'd break it down into 23 times 50 and 23 times 7. You'd go look up those two values on your tablets and then just add the results. They even had tables of squares and used a clever algebraic trick to turn multiplication problems into simple lookups. Now, these ancient methods were amazing workarounds for the tools they had. But the single greatest leap forward in the entire history of multiplication wasn't a new algorithm. Nope, it was a new way of writing down numbers. I mean, just look at this. Try to multiply 125 by 9 using Roman numerals. It is an absolute nightmare. The system itself is fighting you. You can't just line things up. It's a mess of simple shuffling, because it just was not designed for this kind of work. And then this happens. The Hindu-Arabic numerals we all use today. Suddenly, the problem is crystal clear. It's structured. It's ready for a systematic process. This wasn't just an improvement. It was a total revolution. And the reason this new system was so powerful really comes down to 2 simple but totally genius ideas working together. First, place value. The idea that a 3 in the hundreds column is worth more than a 3 in the ones column. And second, the concept of 0 as a true placeholder, which gets rid of any confusion between, say, 34 and 304. Here is the absolute key takeaway. The Hindu Arabic system isn't just a new set of symbols. It's a full-blown operating system for doing math. It creates the whole architecture that lets you run the software, the actual algorithms. You simply cannot install modern software on an outdated operating system like Roman numerals. It just won't run. So, once this powerful new operating system was in place across the world, mathematicians could finally get to work designing the perfect apps for calculation. And this led directly to the methods that we still recognize in classrooms today. And two main algorithms really came to the forefront. On the left, we've got the lattice method. Here, you fill in a grid with a bunch of single-digit products, and then you just sum up the diagonals. And on the right, you have long multiplication, which is probably what most of us learned. You create these partial products and then add them all up. As you can see, they both get you to the same answer, 37,345. But what's so fascinating is the trade-off they represent. The lattice method is brilliant because it separates the jobs. You do all of your multiplication first, get that out of the way, and then you do all your adding. This separation really lowers the mental strain, which means you're less likely to make a silly mistake. Long multiplication, on the other hand, is faster and takes up less space, but it forces you to juggle everything at once, multiplying, carrying, and adding, which is way more abstract and demanding on your brain. Okay, but here's the thing. No matter which of these algorithms you prefer, they both rely on one final, absolutely critical piece of technology. And this is what brings our entire story right back to where we started. We're back to our humble multiplication grid. But now we can see it with totally new eyes. This isn't just some chart for kids. It is the final, perfected, super compact version of what the Babylonians were doing with their massive libraries of clay tablets. And this is its real job. The multiplication grid, once you memorize it, becomes the read-only memory, the ROM for your brain. It's the essential preloaded data that we install in our heads so that the software, like long multiplication, can run smoothly and efficiently. So when you look at that simple grid, you're really looking at the finish line of an incredible 4,000-year marathon. You're seeing the pure process of the Egyptians, the massive databases of the Babylonians, the operating system revolution of the Hindu-Arabic numerals, and the efficient software of modern algorithms. All of it coming together, all of it powered by this one elegant piece of tech that we carry around in our minds. It really makes you wonder, doesn't it? What other simple things that we totally take for granted? A calendar, maybe a map, the alphabet itself. What other things are actually the perfected results of thousands of years of human struggle and ingenuity just hiding there in plain sight?